Today, I'm giving you an introduction to a fantastic module known as Streamlit. Now, Streamlit is something that we can use to really quickly build interactive user interfaces in Python. It's really designed for working with data-based applications, things like LLMs, machine learning, data science, but in truth, you can use this for pretty much anything. Now, over my 10 years working with Python, this is one of the best modules that I've used, and it's definitely the easiest and fastest way to spin up a really quick website that can interact with your Python application. So with that said, let's get into the video. Let me tell you a bit more about what Streamlit is, and then we'll build a sample application that will go over some of the core features so you can learn how to use it and then go and implement it in your own applications. So here's a quick look at the application we'll be building. You can see that we have a file import here, so I've just imported a CSV. It gives us a preview of what the data looks like in the different values, gives us a summary of the data, so you can see that it tells us the mean, standard deviation, minimum, maximum values, etc. Allows us to filter the data, so in this case I've selected city, and then I can filter this by the city, so in this case I could look at, say, New York, and then we can actually plot the data here as well, so I can plot the date against the temperature for the New York data, and there you go, we get a nice chart. Now, believe it or not, this entire thing is made in about 40 lines of code. So let's go over to the code editor, start installing Streamlit, and I'll show you how we implement all of these different components. So in order to use Streamlit, we need to install it. So the first step here is to use pip from our command line or terminal to install Streamlit. So what we're going to do is open up something like VS Code, which I have right here, and then type pip install Streamlit. Now I'm going to go with pip 3 because I'm running on Mac. If you're on Mac or Linux, it'll be pip 3, and if you're on Windows, it will simply be pip. So let's go ahead and run that command. And if for some reason your pip command does not work, as always, I'll leave 2 videos on the screen that will show you how to fix this. Now, after we install Streamlit, we're going to install a few other modules as well. So we're going to install pandas because we need that for this specific tutorial, and matplotlib, which will allow us to create some charts. So let's install those as well. You can see I already have them installed. Okay, so once Streamlit is installed, we can test it out. And in order to test it out, we can type Streamlit and then hello. Now, if this command works, it means Streamlit is running successfully, and this should open up a browser tab for you and show you some output here in your terminal. Now, in order to close this, you can hit Control-C on your keyboard. That should stop that, and then we can move on to creating our own Streamlit application. Now, for our first application, we're going to begin by making a Python file, which I've done right here, main.py, and then we're going to import Streamlit. So I'm going to say import Streamlit as ST, and we're going to spell Streamlit correctly, just so that we have a short form here and we don't need to type Streamlit every single time. Now, the first command to be familiar with here is st.write. Now, this is kind of a magic command, and what I mean by that is that you can pass pretty much anything to write, and it will automatically use some defaults from Streamlit to plot it on the screen. So whether this is a string like hello world, or whether you want to pass maybe an array, or you want to pass an object, or you want to pass a pandas data frame, you can pass pretty much anything here, and it will automatically be written for you. So let's go with something really simple like hello world, and let's see how we would run this application using Streamlit. So to do that, we're going to open up our terminal, and we're going to type Streamlit, run, and then the name of our app, which in this case is main.py. Now notice I'm in the same directory where my file is. That's why this will work. But we're using Streamlit run, passing our script, and then this should open up a browser window for us that has the UI that we specified. So let me open up the browser here. It's just on my other screen, and you can see that we have hello world. Now, if we go back here and we decide to change our code while this is running, so st.write, and let's write maybe an object where we say key, and we have maybe an array here that says value, and I save. If you notice when you come back here, you'll see that it says the source file has changed, and we have rerun and always rerun as options. If you want it to automatically rerun and update anytime you change the source file, you can click on always rerun. If you just want to rerun it manually, you can click on rerun. Notice when I do that, it displays this kind of JSON or Python object value for me, and that's the magic of using this st.write command that can pretty much write anything that you want. Now, if you want more customization, you can use specific functions that will write maybe different widgets like sliders, or you can have some more control over writing like a line chart or a table, and I'm going to show that to you in 1 second. Now, as you can see here, you really don't need to be a web development expert in order to create something cool with Python. However, if you're interested in strengthening your overall programming and problem-solving skills, our sponsor, Brilliant, can help you achieve that. Brilliant is where you learn by doing, with thousands of interactive lessons in math, data analysis, programming, and AI. They use a first principles approach, meaning you'll get the why behind everything. Each lesson is interactive and filled with hands-on problem solving, which is 6 times more effective than just watching lectures. The content is created by award-winning teachers, researchers, and pros from places like MIT, Caltech, and Google. Brilliant focuses on improving your critical thinking skills through problem solving, not memorizing. While you're learning specific topics, you're also training your brain to think better. Learning a bit every day is super important, and Brilliant makes it easy. Their fun, bite-sized lessons fit into any schedule, helping you gain real knowledge in just minutes a day. It's a great alternative to mindless scrolling. Brilliant even has an entire suite of computer science plus Python courses that take you from complete beginner to expert with hands-on lessons that cover the important concepts you need to master. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/techwithtim or click the link in the description. You'll also get 20% off an annual premium subscription. So now that we've got the basics down here, let's build an entire application, specifically that demo app you saw before, so you can see a lot of the different features that Streamlit has. So let's close our terminal and delete this and just import a few other things that we're going to use. So we're going to say import pandas as PD and then import matplotlib.pyplot as PLT. Okay, great. So now after this, we're going to create a title for our application. So we're going to say st.title, and this is going to write some title text for us. So I'm going to say simple data dashboard as the title. Now again, if we save and we go back here and we click on rerun, you can see that we have the new title. Okay, so let's go back and let's continue writing. The next thing that I want to do is create a kind of file upload window or a file upload button. So in order to do that, I'm going to say uploaded_file is equal to st.file_uploader. This is a widget that's provided by Streamlit, and then we can give this widget a name or kind of a label. So we're going to say choose a, in this case, CSV file, and then we can specify the type of file that we want to allow it to be uploaded. So in this case, I'm going to say type is equal to CSV. Now, obviously, you can change the type here, or you can provide multiple types, but in this case, we're just going to go with CSV. Now let's go and actually see how we can use the uploaded file and learn a bit about how Streamlit works in the backend. So what I'm going to do is say if the uploaded file is not none, then what I'll do is just write something on the screen. So I'm just going to say st.write, and I'm going to say file uploaded. ... Now this won't be the finished application, but I want to show you how this works. So Streamlit will actually automatically rerun the Python script every time something changes. Now what I mean by change is that we could be changing the source code, or the user could be interacting with some type of component and actually end up changing the state of the application. So in this case, if the user uploads a file, what's going to happen is the Python script is going to be reran. That file is going to be maintained in the state of the script or the Streamlit application, and then when we get to this if statement, this will change, so the uploaded file will not be none, and will end up rendering file uploaded. Now I know this seems a little bit strange, and it's kind of unintuitive to how you'd build a web app using something like JavaScript or HTML, but anytime the user kind of interacts with the page and makes a state change, like uploading a file, the entire thing reruns. We re-execute the entirety of the Python code, but the state is maintained for whatever what was updated. That just means any logic that you have here, like checking the value of a variable, will be ran again, so then we can actually rewrite or modify the page and change it based on what the user just did. So let me show you what I mean by that. If I come back here and I refresh, you can see that we have a file upload. So now we just need a CSV file to upload. I'm going to leave one linked in the description in the GitHub that's there. So if you want to download a CSV file, you can do it from GitHub, or you can just use your own. But to browse files, you can see I have one in my downloads here. So let me go ahead and open that. And you can see now that it says file uploaded. So as soon as I browse the files here and I change the state, this Python script was reran, and that's why this if statement changed to be true, and then we rendered file uploaded. Okay, so now what we're going to do is, rather than just rendering the file upload, is we're going to read this in as a pandas data frame, and then we're going to write the pandas data frame. So to do that, we're going to say data frame is equal to pd.read_csv, and we're going to read the uploaded file. Next, what we're going to do is display a subtitle So we're going to say st.subheader, and this is going to be a data preview. So you can see pretty straightforward. We're just displaying, well, a title or data preview. If we go back and look at this and we go to always rerun now, you can see that we have data preview. Okay, next we want to actually write the data frame. So we're going to say st.write, and we're going to say df.head. Now this just gets the first 5 rows from our data frame. We pass that to write, and write will automatically handle rendering that for us. So again, if we go back here, you can see now that we have a preview of our data frame showing up. Okay, so let's see what we want to display next. Well, we want a summary of the data. So we're going to say st.subheader, and we'll say data summary, and then we're going to say st outside of the parenthesis here dot write, and we are going to write the data frame dot describe. Now when we describe the data frame, that's going to give us all of those entries you saw in the demo, like the average value in all of the columns, the count, the max, the minimum, etc. So just to show you that, if we go back here, you can see now that we have data summary, and this table is interactable, and if we wanted to modify the table, we could actually use some different commands from the documentation, but we're not going to look at that right now. I'm just trying to give you a quick introduction. Okay, so we have the subheader, we have the data summary and the data preview, and the next thing is to filter the data. So to filter the data, same thing, let's do another subheader. This is going to say filter data, and then we need to pass some widgets that the user can interact with. So first thing, let's grab all of the unique columns that we have. So we're going to say columns are equal to data frame dot columns dot to list. Now that's just going to give us all of the columns in a Python list. And then we're going to say selected underscore column is equal to, and we're going to say st.selectBox. Now this is a widget that's going to give us a drop-down list of all of the different values that we pass to it. The first thing we pass is kind of the prompt or the label for this. So we're going to say select column, okay, to filter by. And then next, we're just going to pass all of the columns. So this is now going to give us a drop-down list with all of the different columns. Let me make this a little bit smaller just so you can read all of this. Okay, so we're going to have all of the different columns. Let's have a look at that right now if we save. When we come back, you can see that we have filter data. It says select column to filter by, and then we have a bunch of different options that we can select here. And every time we select this, it's going to rerun the Python script, caching all of the data that we had before, but allow us to run the logic that comes beneath. Okay, so we have selected column. We're then going to have unique values. And what I'm going to do is grab all of the unique values from this column. So I'm going to say df, and then selected column, and then this is going to be dot unique. Okay, so that grabs all the unique values from this particular column. The reason for that is that once we have a column, we can then select a value within that column and grab all of the different rows that match that value. So now we're going to say selected underscore value is equal to st.selectBox, okay? And we're going to say select value, and then we're going to go with unique values like that. Okay, so let's go back and look at what this gives us. You can now see that we have 2 select boxes. We have a city, and once we select something like temperature or city or whatever, it gives us all the unique values. So it's updating that in our script, and then we can select one of the unique values. Okay. So now that we're able to filter our data, what we want to do is display that filtered data and then plot that on the screen. So in order to display that, we're going to say filtered underscore data frame is equal to data frame. And then this is going to look a little bit weird if you've never used pandas, but this is how you can do a filter. Inside of the square brackets, we can say data frame again, and then we can say selected underscore column double equal to selected value. All this is doing is going in our data frame, and it's grabbing all of the rows where the data frame at the selected column is equal to the selected value. So where this row has that value in the correct column, we're going to select it. Okay, then we can write it. So to write it, we're going to say st.write, and then we'll just write the filtered data frame. Again, whenever you want to display something and you don't know how to display it or the specific command, you can just use write, and it will automatically be displayed for you. So let's go back, and you can see now that it displays that data for us. Great. Okay, now we want to plot this. So to plot this, we're going to say st.subheader, and then we're going to go with plot data. And then in here, we're going to select, the X column and the Y column that we want to plot. So we're going to say X underscore column is equal to st, and we'll go with a select box again. We're then going to say select the X axis column, and then we're going to pass all of our unique columns. And then we'll do the exact same thing for our y column. So let's copy this and paste this down here and just change this to y and y. Okay, so now we're going to grab the X column and the Y column. Now I want to display a button, and when we press the button, I want to generate a line chart that uses the data from the X column and the Y column. So I'm going to say if st.button, this is as easy as it is to put a button here, and we're going to say generate chart or generate plot. Now what this is the name of the button, and then if I press the button, this is true, and then we'll go inside of the if statement. So again, as soon as I press this, then this logic will happen inside of the if statement. So now I'm going to say st.line underscore chart, and what I'm going to do is pass my filtered data frame, and I'm going to say .set underscore index. I'm going to set the index as the X column, and then I'm going to take the Y column values like that, and that's really all we need to do to plot that. Okay, now otherwise, so just going to have an else statement here. So if we've not actually uploaded a file, then I'm just going to say waiting on file upload. So I'm going to say st.write and waiting on file upload ... Okay, so kind of basic here, but I just want to show you a simple example. So let's go back here and let's look at this. And you can see now that we have, if I refresh here, waiting on file upload, we can upload a file. So let's upload the CSV file. We get the data preview, the data summary. We have the ability to filter the data. So I can go maybe by city and then select, say, New York. And we can view all of the values that we have for New York. Then I can plot the data. So I'm going to plot the date as the x-axis and maybe the wind speed as the y-axis. And when I press this button, we generate the plot. There you go. So you can see when the button was pressed, we come in here, this if statement now runs and is true, and then we render whatever is inside of here. So a really intuitive and easy way to actually kind of respond to different events, and that's because once this changes, we rerun the Python script maintaining whatever the previous state was. In this case, it's pressed, so then we execute this code. So that pretty much wraps up the application here. Obviously, there are a million other things you can do here using Streamlit. If you want to reference the documentation, I'll leave a link to it in the description. There's all kinds of widgets you can make, like sliders. You can have text inputs. You can see that they have that right here. And there's all kinds of advanced features. You can have callbacks. You can render specific data in different ways. You can change the layout. This isn't meant to be an in-depth full tutorial, but just an introduction to give you a sense of what you can create and to encourage you to go and explore this module. So with that said, I will lastly just mention that you can actually deploy this app very quickly, which is another advantage of Streamlit, and this can work on mobile and desktop. If you click the deploy button here from the UI, you have the option to deploy this completely for free using the Streamlit Community Cloud. So if you click on deploy now and go through the prompts here, it's going to say it's not connected to GitHub, blah, blah, blah. There's a few things you need to do here in order to deploy this, but you can connect it to GitHub and then it will automatically get deployed for you, and then you'll have some URL that's public that anyone can access where you can view this application. This is really good when you want to build a quick UI for interacting with AI apps or things like custom LLMs, and that's why a lot of people have been using Streamlit recently. Anyways, if you guys enjoyed the video and you want more on Streamlit, make sure you leave a like and subscribe. Let me know in the comments down below, and I will see you in the next video.